of refraction. Now, if I know you are, you've seen this already. Have you seen in the plaza, or there is an event sa plaza, or even in malls, na daw it's a decorative material that there are actually here daw gatipon ng mga nylon nga nagamukaraay. May mga nylon dyan na. Tapos, sa dalim na, may sulo. May sulo dyan, usually pula, ganda ang sulo. Tapos makita nyo ang mga sulo sa punta ka mga nylon. Nakita nyo ra? Ano yung nabigya sa mall?
Sir.
No, kita nyo. Okay.
Ang
This one is an example of what we call as the total internal reflection. So it's the total internal reflection. The one that is happening on your fiber optics. Your nylon is an example of a fiber optics. So if light are from this portion here, and you will just see the light on the edge of the fiber optics, it's because of no light escape from the sides. It's just only on the edge. And because of the total internal reflection. So what is the total internal reflection? Here, instead, light wave will actually move out from the medium because of the refraction. It's actually did not move out. It's actually returned to the medium. Nagbalik sa medium. Let's say, for example, here again, water and air. So this is your water and air boundary, and let's have our normal line. So let's say, for example, first, if you will have your light ray coming from the water right over here, so it will bend, move here. Then if we are going to increase the angle, okay, increase the angle here. And of course, the angle of refraction will also increase. Then increase it further. Now, if you're going to increase it further, you will see that your refracted ray is already at the surface of the water. Now, if we will going to increase it more, taasan ta pagintana, more pagintana. This one now, your light ray will now return to the water. So, makita mo nga nag-return rin sa tubig ang imo nga light ray. So, this is what we call as the total internal reflection. Instead, the light wave will move out from the medium. It actually returns to the medium because of the angle of incidence. This yellow line here, this one here, yeah. This is what we call as the angle of incidence, which is the critical angle. Okay, the critical angle wherein the angle of refraction is exactly the angle of refraction is exactly 90 degrees from the normal line. Now, the question is, for water, what will be the critical angle? So, we will going to solve. Bala natin ang critical angle ka tubig. So, sudon, amo dyan nga area, amo dyan nga angle, ginatawag dyan nga critical. Kaya because that is already the angle the angle of the refraction is exactly 90 degrees from the normal line. So if you will have your N1 is your water, your N2 is your air, the angle of refraction is 90 degrees. So what will be the angle of incidence? So sine angle I all over sine angle R is N2 all over N1. So therefore, angle I is equal to sine angle R multiplied to N2 all over N1 multiplied to sine negative 1. So your angle I will be equal to sine 90 multiplied to N2, which is 1, all over 1.33, and this is sine negative 1. And your angle I, if you're going to solve this, is 39 degrees. So therefore, the critical angle, 49 degrees, sorry, 49 degrees. The critical angle class of water is 49 degrees, water to air. So if it is 49 degrees, when it leaves the water at 49 degrees, it will refract exactly 90 degrees. So definitely beyond 49, 50, at 50 degrees and above, no, to 50 degrees to 89 degrees, your light wave coming from the water will return back will return back to the water. So it will have a total internal reflection. Right? And because of this discovery, no, because of this discovery, it improves our telecommunication. Ang telecommunication natin nag-improve. Long time ago, we are using cable wires. So, for example, in telephone, katong mga panyempo, kung magtawag ikaw, ang gagwa, no? Kung magtawag ikaw kung manawag ikaw, may abi sample papanawag mo daw gahid daw duro disturbances daw duro disturbances sa imo papanawag kay it's because cable katong ginagamit ang imo nga limag may tendency nga magwa, no, the electrical signal kay ti dibla it's from sound to electrical signal, then tablag into electromagnetic wave using the radio wave, then it will receive with the amplifier, again it turn into electrical signal, then back to your phone and convert into sound. So kato kay cable ang ginagamit, the tendency nagakawas ang imo nga mga electrical signal, nagagwa tana. Tapos pwede nga masudlan man kang iba nga mga interruption or may mga interference nga gasulod from outside. So later they discovered the fiber optics. So in the fiber optics, amo na kadya ginagamit ato sa mga telephone ta kag sa aton mga internet connections nga iba. So because if you will have your fiber optics parehas kang nylon baka to kay na, no? If this is the bigger part of or the bigger ano ra, picture of the fiber optics, if you will have your light ray class, if you will have your light ray, for example, kaya sa nylon mo to, ibunggo dala ang light, what kung piraman i ang critical angle na, dapat mo man ang critical angle kang imo nga fiber optics. So ibunggo dala at a certain critical angle, beyond the critical angle, it will just bounce, class, mabounce lang ra until nga magwa tana. So if you look at it, you will see that the critical angle or the light wave class from outside, no, it enters the fiber optics. It will just bounce back from the edges. It will not move out. Wala ti may kakawas, wala may kasalad. So tendency na mag-abot sa punta kung ano gidto ang imo nga message, pag abot sa punta, mabaton gidto kang imo ginatawagan ang imo message without any interruption. So as of now, we're using the fiber optics in the telecommunication companies. It's a big help. So it's the process or the concept there is the total internal reflection. All right. So any question with this? Any question? Let's now proceed. Yes, may question pa, Raren?
Answer.
Okay, let's now proceed on lenses. Sa lenses, hindi tagid magbira katutok. Kay ang lenses natin, simply lamang naman ng lenses ta. Kay ang concept natin sa mirror, same lang man sa lenses. So there are two types or two kinds of lenses. We have the convex lens and the concave lens. Okay, your convex lens is bulged outward or thinner at the inside or at the middle and ano, thicker at the middle and thinner at the edge. Okay, naga-bulge outward. Amo lang ating convex lens. Our concave lens is that bulge inward wherein it is thinner at the center, at the middle, and thicker at the edge. Okay. So, hindi ka magtalang, Ridja, ang imo nga convex lens naga-work ta na parehas kang imo nga concave mirror. So, this one is same with your concave mirror. Your concave lens works the same as your convex mirror. All right. So here, your concave lens or your convex lens, I mean your convex lens class is projects parallel beam of lights into a single real focus. So real focus ang aton dyan karang ginag-deal. Kaya real focus ba sa concave? And then sa aton nga a concave lens, gina-deal natin ang virtual focus. So same lang gid na, parehas lang. Kung kung may ano ikaw, kung may problem ikaw ga deal for example, so sa ating nga convex lens, gadil kita ka positive focus. Sa ating nga concave lens, gadil kita ka negative focus. Sa ating convex mirror, gadil kita ka negative focus. Ang ating nga concave mirror, gadil kita ka positive focus. Diba? Balis ka, doon nyo lang ang description, amo na natana. Same Japon. So we can use also the lens equation. We can use also the ray diagram. But then in the lens, I will just use the lens equation or the mirror's equation. Amo na lang gamitin ta. Hindi natin mag-draw. Ito na natin mag-focus sa mirror sa drawing. Okay? So any question with that? Any question? May question kita? Okay then? Okay. So I hope that this all is clear with you. Okay, class. So let's now proceed on our uh, advanced physics class. But I will have a break first for 10 minutes. Ma-break ako for 10 minutes. Then mabalik kita kay 20 minutes naman yung discussion. It's just a little discussion. No, i-upload ko karoon ang module nga dyan na nalipatan dyan i-upload. This is all about density, no, density. So matok ko lang kung ano kagamay nga density, but then density is already discussed when you're in elementary. So ma-break lang tayo at 10 minutes, okay? And then I'll be back after 10 minutes. Please hold on. Tell your other classmates where ang kabalalik ang iba. Okay? Ang balin mo nga mabalik. Okay.